So let's look at section 1.5 now, solving inequalities, still in chapter 1, equations and inequalities. So our objectives in this section are going to be to use interval notation, which hopefully is very familiar, but just be a good refresher if it's been a while. So we're going to use interval notation, and we need to know how to do that to show the solution sets of inequalities. So then we're going to use properties of inequalities, a little bit different than solving equations. And then we're going to solve inequalities. So first simple inequalities, and then we're going to solve combined inequalities. And this is in preparation for solving other kinds of equations later on. So if you need some review, here's the section you go to, R.2. And I want to do a little introduction of the topic before we jump right in. So inequalities need to be written in number line order. And if you don't think in terms of a number line, let me encourage you to do that, where these are the positive integers, the negative integers, the arrows represent going on infinitely, and it's just a really helpful thing to think in terms of a number line. And when we say graph the solution set of an inequality in one variable, you're going to use a number line to graph it. So if we write this inequality, 2 is less than 6 is less than 3. In words, this means 2 is smaller than x and x is smaller than 3. So another way of saying it is x is the numbers between, see how it literally is between 2 and 3, not including 2 and 3 because it's a strict inequality. So you can see why somebody came up with symbolic language, because that's a lot of words to say the very same thing. So this is equivalent to the two separate inequalities. 2 is less than x and x is less than 3. So it's incorrect to write 3 is less than x is less than 2 because there aren't any numbers that are less than 2 and bigger than 3. So that wouldn't make any sense. And then this next one doesn't make any sense because you're saying x is bigger than 2 and x is bigger than 3. Well, all the numbers bigger than 2 and bigger than 3 is all the numbers bigger than 3. So that's redundant. You don't need that extra information there. So all of the inequalities need to open in the same direction, and the numbers need to be in number line order. 2 is to the left of 3 on the number line, so 2 needs to be to the left of 3 in the inequality notation. So the first thing we're going to do is use interval notation. If we have a and b are two real numbers, then a is less than b, so that means a is to the left of b on the number line. Then an open interval, which is denoted by parentheses, curved parentheses, a comma b, consists of all the real numbers x for which x is greater than a and x is less than b. So we can write it in a single inequality because this is true. So a closed interval is denoted by square brackets, and be very clear and careful when you're writing these notations. If you write something that looks like this, I'm going to say, what is that? And it's going to be incorrect. If I can't tell what it is, then it's incorrect. Okay, so the closed interval has a square brackets, and it's all the real numbers x for which a is less than or equal to x, which is less than or equal to b. So we have the or equal to part is corresponding to the square brackets. We no longer use the open dot and closed dot if that's what you're used to. I'm sorry, that's kind of dated notation that nobody's really using anymore. So the half open or half closed intervals have one side with curved parentheses and one side with a square parenthesis. And this one is a is less than x, which is less than or equal to b. And we could also have the square bracket on the left and the curved parenthesis on the right. And that says a is greater than or equal to x, which is less than b. So we call a the left endpoint of the interval and b is the right endpoint of the interval. And infinity is not a number, and so cannot be included in an interval. So infinity is not a number. So for the right arrow on the number line, we use a curved parenthesis. For the left endpoint, if it's the negative infinity, we use the symbol negative infinity and a curved parenthesis to say this interval keeps on going forever. So never use the square bracket with infinity or negative infinity. Okay, then this table is in your book, so I just put it here for handy reference, and we'll do these examples in class quickly together. And we're moving on to objective 2, which is to use the properties of inequalities. So the non-negative property says, for any real number a, if I square a, I'm always going to get either a positive number or 0. That's the only possibility. So we discovered that when we were using the quadratic formula, the b squared in the quadratic formula is always a positive number for this very reason. The addition property of inequalities says if a is smaller than b, and we add some number c to both sides, the inequality is preserved or stays the same direction. And if a is greater than b, then still the inequality stays the same direction if you add any quantity you like to both sides. So add or subtract any quantity, so it can be a number, an algebraic expression, from both sides of an inequality. And as usual, we don't say the long part about without changing the solution set. Okay, now this is in a red box because it's different and important and easy to forget. So the multiplication property for inequalities says, if I have a is smaller than b and c is a positive number, then when I multiply both sides of the inequality, it stays heading in the same direction. But if a is smaller than b and c is a negative number, then when I multiply by c, the inequality reverses direction. So again, if a is greater than b and c is positive, then ac stays greater than bc. But if a is bigger than b and c is negative, then the inequality reverses. So if you think about why this works, take two simple numbers. 1 is smaller than 3. We know that's true. So now multiply both sides by -4. And the numbers you get have traded positions on the number line. So think about what's happening when you multiply by a negative number. You're increasing the distance from 0, but you're reversing it to go on the other side of 0 on the number line. So the numbers trade places. So in plain English, if you multiply an inequality by a negative number, the direction of the inequality symbol reverses. Okay, so we're going to do some simple solving of inequalities. We'll do that one together in class and then talk about the answer, because the answer always has three parts: set notation, interval notation, and a graph. So I want to do those together to make sure and emphasize that. Okay, so now we have the reciprocal property, which says if a is a number bigger than 0, then if I do the reciprocal, that has to be bigger than 0 also. So you can't make a number negative by doing the reciprocal. And if a is a negative number, its reciprocal is negative. And then these go both directions. So in plain English, taking a reciprocal does not change the sign of a number or expression. It does, though. Let's think about this. 2 is less than 5, right? So now do reciprocals. Oh, now a half is bigger than a fifth. So if I do reciprocals of two numbers, the inequality reverses. So now let's solve inequalities. And solving an inequality means to find all values of the variable that make the statement true. The set of values is called the solution set of the inequality. So when you solve a linear inequality in one variable, it's just like solving a linear equation in one variable, except what? So let's talk about this in class. If I have ax plus b equals 0, and I'm solving that, but then I have ax plus b is greater than 0, or ax plus b is less than 0, what's different? So let's talk about that so I can emphasize it. Okay, and then we'll do this example together. So section 1.5 is solving combined inequalities. So solve combined inequalities. So recall that the inequality 4 is smaller than x minus 2 is smaller than 7 is equivalent to the two inequalities 4 is less than x minus 2, and the word and is important here, and x minus 2 is smaller than 7. So basically we're solving two smaller inequalities here. So we have x is bigger than 6 and x is smaller than 9. So the word and is a really important part of the solution. So you can either solve the two equations separately and get x is between 6 and 9, or you can do it in one step by thinking of this as having three parts and saying add 2, add 2, add 2. So you're trying to get x by itself in the middle, and you get the same result. So let's look at this example in class together, and then we'll be good to go on this section.